VLSos here. This is a video lesson on dimensions. The concept of dimensions is very useful in mathematics to distinguish between different kinds of objects. I've started here with labeling 1D, 2D, and 3D. This is for 1 dimension, 2 dimension, and 3 dimension. And under the 1 dimension, or 1D, I have an object, which is a line. A line is a name for a very general type of thing that we can study in mathematics. And when we measure lines, we measure 1 dimension, and we often call a 1-dimensional measurement a distance. Before we give examples of 2-dimensional object and a 3-dimensional object, let's define what we mean by dimension in very general terms. The dimension of an object is the number of measurements required to describe or locate anything within it or within an object. This line is a mathematical object. It's 1-dimensional because we only need one measurement to describe the line, its length. Or, if we wish, we could choose a point as the origin and describe or locate where we could be on that line as a distance from that origin or from that end point. An example of a 2-dimensional object is any shape. I could draw an example of a shape. In this case, it'll be a trapezoid. A trapezoid is a mathematical object. It's 2-dimensional. 2-dimensional objects we call shapes. When we measure them, we measure the area within the shape. We call the measurement that is 2-dimensional an area. To locate any point within the shape or on its edge, we would need at minimum 2 measurements. We could choose any point to be an origin, and we would need a measurement horizontally and a second measure vertically in order to find any point or describe or locate any point within that shape. An example of a 3-dimensional object is difficult to draw on paper because paper is flat, paper is 2-dimensional. But we have ways of helping visualize 3-dimensional objects. 3-dimensional objects are objects like in the real world. One of the simplest objects that we can draw is a box or a cube. And we'd need some strategies in order to help us visualize what that would look like on a piece of paper. Sometimes we draw dotted lines that would be behind the front. Sometimes we'd use the strategy of shading what is on the bottom of this 3-dimensional representation. Objects that are 3-dimensional are called solids or a solid. And when we measure a solid, we are measuring volume, the amount of space that fills the solid. Solids are 3-dimensional because in order to locate any position within the solid, we would need a minimum of 3 measurements. we would have to know, if we chose any point to be an origin, we would have to know horizontally how far away we are, vertically how far away we are, and then very often the third dimension is called depth, or how far back we are, which is why we call it three-dimensional. Now for fun, we can put in this presentation something that we can consider to have no dimension, or a 0D object. And that would be just a point. Points may be considered to be zero-dimensional because they have no measurement. A point drawn on a piece of paper might have a different size, but a point as a concept is an infinitely small location. It doesn't have any extension. There's no measurement to be made. It has zero dimension. And for fun, we could extend this and think of what it might mean to be four-dimensional. Now, we live in a three-dimensional world in the sense that the things that we can touch and interact with in the real world have three dimensions. The fourth dimension, if we would consider it, is often thought of as time. And a way that we can represent this on paper is to first imagine a cube. Drawn on paper, we might be able to visualize a cube. A cube is three-dimensional. Where the fourth dimension might come in is imagining that this cube, over time, could shrink or expand. So we have the three-dimensional solid of the cube, but then the capacity for the cube to, over time, change size. Time would be the fourth dimension. To get the illusion on our paper of the cube changing size, we could draw a smaller one inside and then connect the corresponding vertices of the cube to attempt to give the understanding that the cube is both large and small, and everywhere in between that can shrink and grow. This is just for fun, but an object that we would consider four-dimensional can sometimes be given the word tesseract.